The notorious Bermuda Triangle in the North Atlantic Ocean makes people, ships, and airplanes vanish into thin air. Some experts blame bad weather conditions. Others are sure the reason is heavy traffic in the area and human error. Many people believe in conspiracy theories, aliens, the lost city of Atlantis, or even a massive meteorite lying on the ocean floor. There are also those who deny there's anything unusual about the triangle, and still, the mystery remains. But few people know that the South Atlantic Ocean has an enigma of its own. Well, not the ocean itself, but a patch of space above this area. It's dubbed the Bermuda Triangle of space, or the South Atlantic Anomaly. There, Earth's protection against solar radiation is much weaker than anywhere else. When spacecraft get into this region, all kinds of serious problems occur to them. For example, their equipment can fail or break down out of the blue. When NASA was launching its $2.5 billion Perseverance rover in July 2020, the space agency planners had to do their best to avoid the Space Bermuda Triangle. Otherwise, it could have easily wreaked havoc on the spacecraft headed for Mars. This bizarre region stretches from Zimbabwe to Chile. The anomaly itself seems to be connected with one of the two Van Allen radiation belts. These belts are zones of intense radiation that comes from the solar wind. Charged particles get caught by our planet's magnetic field. They form two rings that surround Earth, stretching from 400 to 36,000 miles above the surface. The inner Van Allen belt is made up of mostly protons, while the outer is mainly electrons. By trapping the particles, the two belts protect you and our planet from getting harmed by solar radiation. The South Atlantic Anomaly lies in the region where the inner Van Allen belt comes very close to the planet's surface. In this place, Earth's magnetic field is especially weak. Nothing prevents cosmic rays from reaching as far as a mere 120 miles above the surface. The more solar radiation, the more high-energy particles gather over the South Atlantic Ocean. The problem is that this radiation hotspot sits so low that many satellites have to travel through it while following their orbits. There, they get bombarded by protons at a speed of 18,000 hits per square inch per second. No wonder it affects all the electronic systems on board the spacecraft. For example, the Hubble telescope passes through the Space Bermuda Triangle more than 10 times a day, and it can't collect information when it's in that region. If the equipment isn't put into safe mode, all spacecraft systems can fail. Plus, the more complicated electronics become, the more problems occur in the area of the South Atlantic Anomaly, and the more costly the damage is. The SpaceX CRS-1 Dragon spacecraft almost went out of control in October 2012. Attached to the International Space Station, it had serious problems while passing through the magnetic anomaly. Luckily, those issues were short-lived. In March 2016, the Japan Aerospace Exploration Agency lost contact with its satellite Hitomi. It was launched about a month before to study processes happening in the universe. Later, it was found out that the spacecraft had broken into pieces and crashed down to Earth. One of the motion sensors reported that the satellite was rotating, but in reality, it was stable. When the control system tried to prevent the unwanted and non-existent spin, the spacecraft fell to pieces. This accident cost almost $280 million and 3 years of preparation. But returning to the Earth's magnetic field, why is it weaker above the South Atlantic Ocean? Rather than being a perfect sphere, our planet bulges in the middle. If you measured Earth's diameter at the equator, it would be 27 miles wider than the pole-to-pole one. In the areas where there's a dip, charged particles from space can get closer to our planet's surface. The magnetic field is created when liquid metals flow in our planet's outer core. This generates electric currents and also gives Earth its south and north poles. But these poles aren't constant, because our planet's magnetic field is constantly shifting. Sometimes it's getting weaker, and at other times, it's growing stronger. Right now, the Earth's magnetic field is weakening. This process started more than 1,000 years ago. Scientists don't deny that one day, Earth's magnetic poles might flip. Then, the North Pole will become the South, and vice versa. Such a phenomenon has been happening all the way throughout the history of our planet. The last time, it occurred around 780,000 years ago. Experts are still unsure if such a flip is going to happen this time. After all, it's not an instant change. This long process can even reverse all of a sudden. Something like that happened 40,000 years ago. At that time, Earth was really close to renaming its north magnetic pole to the south. But that brisk event turned out to be not a full reversal. While scientists were trying to figure out how long the South Atlantic Anomaly had been around, they made a curious geological discovery. It showed what our planet's magnetic field looked like several thousand years ago. The Bantu people were a tribe of ancient Africans who lived about 1,000 years ago in the region of the Limpopo River Valley. Nowadays, this area is inside the South Atlantic Anomaly. Bantu people had an odd ritual. During droughts, they burned their own clay huts. They hoped such a sacrifice would make it rain. But when clay burned at high temperatures, the magnetic minerals in it aligned with Earth's magnetic field. That's why when the substance cooled down, the minerals showed the planet's magnetic field pattern. It helped the scientists learn that the process of the weakening of the magnetosphere started long ago. The clay patterns even specified certain periods of time when the process was especially active: 400 to 450 CE, 700 to 750 CE, and 1225 to 1550 CE. Even better, the researchers likely found the answer to the mystery of the space Bermuda Triangle. They noticed there was something unusual about the boundary lying between our planet's silicate mantle and its liquid iron-nickel outer core. This region is almost 1,800 miles beneath Earth's surface, and that's where a huge reservoir of super dense rock sits. Some experts state that the thing might be tens of millions of years old and thousands of miles wide. It's not 100% clear how a rock, even if it's that big, can interfere with the magnetic field of the entire planet. It might be because it's located right between Earth's boiling outer core and the mantle, which is much stiffer and cooler. The enormous boulder might be disturbing the layer of iron, and it's the very thing that helps to form our planet's magnetic field. Whatever the reason is, exactly under Africa, the magnetic field is reversed, and that's what's likely to cause the anomaly that affects spacecraft. At first, the scientists thought their discovery meant the magnetic field was about to flip again. If it was true, our planet would go through several catastrophic events. The continents would start to lurch in different directions. It would trigger catastrophic earthquakes, lead to the disappearance of many species, and provoke climate changes. Luckily, there's no evidence that the consequences of the pole reversal would be that bad. Even better, it might not happen at all. After more research, it became clear that the Bermuda Triangle of space isn't a sign of an upcoming pole reversal. The events taking place under the continent are more likely to be part of a bigger scale pattern. But the South Atlantic Anomaly is scary enough on its own. If this area keeps growing, it'll cause problems not only in space, but also on Earth. Computers and other electronic equipment will fail or stop working altogether. Right now, the radiation is less intense in the lower layers of the anomaly than in its upper part. But over the past 150 years, the magnetic field in the region has lost more than 15% of its strength. It doesn't mean Earth will be left unprotected from the sun's radiation in the nearest future. Experts are sure this won't happen for at least another billion years. Plus, some kind of magnetic field always existed during the times of the magnetic poles reversal, even though it was weaker and more complicated than the modern one.
Well, well, my cosmic pal, do you ever feel like everything is just drifting apart? Well, your intuition may be right. It turns out something weird is indeed happening in the universe. Since the Big Bang, everything has been spreading out in every direction and getting faster every day. But here's the thing, not all galaxies are moving at the same speed. We have some seriously massive clumps of matter out there that are slowing us down. And there's one giant mysterious gravitational anomaly that's been dubbed the Great Attractor. No, we're not counting me, though we share the same nickname. It's the mystery of mysteries, and it's been pulling us and all the nearby galaxies closer to it for billions of years. Scientists aren't certain what this great attractor is made of, but it's so powerful that it overcomes dark energy, which makes up about 2/3 of the universe. Dark energy is more or less like the universe's energy drink, pushing everything forward and giving galaxies a boost in their movement. So, where is this thing? Hiding in the zone of avoidance, which sounds like a made-up town from a sci-fi movie, but is actually a real place in the universe. There's just so much stuff between us and the Great Attractor – stars, gas, dust – that we can't even see it. Some astronomers think that this is just how the universe ends. Everything clumps together into one giant supercluster, and then boom, big crunch. It's like when you're trying to fit all your clothes into one suitcase and it just ends up exploding everywhere. Now, before you start thinking that galaxies moving is no big deal, let me tell you that this isn't just any ordinary movement. You see, this thing called the Hubble flow dictates that galaxies should be receding from one another as the universe expands. But as luck would have it, that's not what's happening. The Great Attractor is so strong that it even affects our own galaxy, hurtling us toward it at more than 1,000,000 miles per hour. I'll spare you the math, but if we spun around the Sun at that kind of speed, our year would be a mere 18 days long. The Great Attractor was first noticed in the 70s, but our technology wasn't quite up to the task of seeing through the zone of avoidance. Nevertheless, X-ray technology has come to our rescue in recent years, and it has helped us piece together some of these hidden parts of the galaxy. Now, what can this Great Attractor be, you might ask? We can only make assumptions at this point. The most likely solution is that it's a galactic cluster. They are basically the universe's version of a massive family reunion. These bad boys are held together by their own gravity and can pack hundreds or even thousands of galaxies, along with a ton of hot plasma and sneaky invisible dark matter. The X-ray data has revealed a plethora of distant galaxies that we previously didn't know existed. Not only that, but 2 new galaxy clusters have been found, the Norma cluster and the Shapley supercluster. The Norma cluster has a mass of roughly 1,000 trillion suns and comprises thousands of galaxies. It's possible that the Norma cluster is the reason for the Milky Way's high-speed hurtle through space, but it still can't explain the movement of thousands of galaxies around us. However, when scientists peered deeper through the zone of avoidance, they spotted the Shapley supercluster. This behemoth of a galaxy cluster is the largest within 1 billion light-years. It could explain the movement of galaxies in our sliver of the universe. More than 8,000 galaxies create a mass of more than 10 million billion suns. Most scientists have accepted that the Shapley supercluster is most likely the force behind the Great Attractor. It lies in the region where the pull appears to be coming from, and logically, it seems to make the most sense. There's more though. Some researchers take pause at the proximity of the Shapley supercluster to other clusters. Too many galaxies come together in various clusters there, openly defying the Hubble flow. Some experts believe that a large gravitational anomaly is the real answer to the Great Attractor. There have been theories ranging from a supermassive black hole, larger than anything we could possibly imagine, to some sort of life form making a mess in that corner of the universe. The Great Attractor is not the only weird thing we've stumbled upon in the universe, as you can imagine. Have you heard of the red rectangle? No, it's not a new dance move, but an amazing nebula surrounding a star called HD 44179. This star is a lot like our Sun, but it's at the end of its life and is spewing out gas and other materials to create this incredible structure. Some scientists think that the star might actually be a close binary, meaning that it has a partner and that there's a thick ring of dust around it. And even though we've got some ideas about how the red rectangle got its shape, scientists are not entirely sure. One thing we do know for sure is that the red rectangle is a type of nebula called a protoplanetary nebula. And when that happens, there will be a super hot white dwarf star left over, which will give off some seriously cool ultraviolet radiation and make the surrounding gas glow. As for its location, it's about 2,300 light-years away, hanging out in the constellation dubbed the Unicorn. Not all weird space objects are so far away from us in the universe. Some of them may be lurking pretty close to home. In January 2015, two clever astronomers made a prediction that a gigantic planet could be spying on us from our outer solar system. Now, before you start getting too excited, we should point out that they haven't actually seen this mammoth world yet. Their prediction is based on some pretty basic math and computer simulations, so there's still some debate about whether this prediction is true or not. But if it is, this planet, which scientists have nicknamed Planet 9, also called Planet X in the past, could be up to 10 times the mass of our own Earth and about the same size as Uranus or Neptune. What's really unusual about this mysterious planet is that its predicted orbit is extremely elongated, making it unlike any other planet we've seen before. In fact, it's estimated to be about 20 times further from the Sun than Neptune. And it takes between 10,000 and 20,000 years to complete just one full orbit. You might be asking yourself, how can anyone predict a planet they've never seen before? Well, these scientists noted that at least 5 other smaller objects floating around in the distant parts of our solar system seem to be following similarly unusual orbits. By analyzing these orbits, astronomers worked out that there must be a big undiscovered planet out there causing all the fuss. To figure out this mystery, astronomers will be peering into the universe's most powerful telescopes to see if they can spot this elusive Planet 9. However, it won't be an easy task, since an object that is so far from the Sun must be very faint and difficult to detect. Some astronauts have even experienced the Bermuda Triangle equivalent of space while passing through the South Atlantic Anomaly. This is a region in Earth's magnetic field where 2 rings of charged particles come closest to our planet's surface. And as luck would have it, this area happens to be high above the South Atlantic. Computers can go haywire there, and astronauts can see cosmic flashes, possibly because of radiation stimulating their retinas. And it's not just poor astronauts who have to deal with this anomaly. Even the Hubble Space Telescope is unable to make observations when passing through this region. It's a real pain in the telescope's lens. So, what's the deal with this SAA? It turns out that our planet's magnetic field is not perfectly aligned to its rotation axis, which causes the 2 particle rings to tilt. And as a result, we end up with this region that's causing all sorts of trouble. Well, space is just one thing or another, isn't it?
The Moon is the second brightest object in our sky. At the same time, among other astronomical bodies, it's one of the dimmest and least reflective. Our natural satellite only seems bright because it's so close to Earth. For comparison, our planet looks much brighter when you look at it from space. It's because clouds, ice, and snow reflect way more light than most types of rock. Triton, Neptune's moon, has all its surface covered with several layers of ice. If this satellite replaced our current moon, the night sky would get 7 times brighter. The closer the moon is to the horizon, the larger it looks. This phenomenon is called the moon illusion. One of the theories explaining it claims that the atmosphere plays the role of a magnifying glass, which makes the moon look bigger. In reality, if the atmosphere had a say in it, the moon would actually look smaller, not bigger. Most experts believe that the illusion is created by your own mind. It can increase the moon's size more than twice. When Earth's satellite is high up in the sky, you don't have any visual cues about how far away it is. But when it's near the horizon, you can see objects surrounding it in detail. It makes the moon look larger. But it's just one of the many theories explaining the phenomenon. By the way, you can trick yourself out of this illusion if you bend down and look at the moon upside down through your legs. 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it's no larger than an average car, it's still a big deal. Out of more than 1 million asteroids astronomers know about, it's only the second one to orbit our planet. Called 2020 CD3, it's our temporary mini-moon. It won't be with Earth for long, though. The asteroid is following a random orbit and is slowly drifting away. Temporarily captured objects, such as 2020's CD3, are rare. They need to have specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. A transient lunar phenomenon is one of the most enigmatic things happening on the moon. It's a short-lived light, color, or some other change on the satellite's surface. Most commonly, it's random flashes of light. Astronomers have been observing this phenomenon since the 1950s. They've noticed that the flashes occur randomly. Sometimes they can happen several times a week. After that, they disappear for several months. Some of them don't last longer than a couple of minutes. But there have been those that continued for hours. The year was 1969, one day before Apollo 11 landed on the moon. One of the mission participants noticed that one part of the natural satellite was more illuminated than the surrounding landscape. It looked as if that area had a kind of fluorescence to it. Unfortunately, it's still unclear if this phenomenon was connected with the mysterious lunar flashes. There might be more metals, for example titanium or iron, in lunar craters than astronomers used to think. The main problem with this finding? It contradicts the main theory about how the moon was formed. That theory says that Earth's natural satellite was spun off from our planet after a collision with a massive space object. But then, why does Earth's metal-poor crust have much less iron oxide than the moon's? It might mean the moon formed from the material lying much deeper inside our planet. Or these metals could have appeared when the molten lunar surface was slowly cooling down. The moon's gravity is about 17% of that on Earth. If you weighed 200 pounds on our home planet, on the moon, your weight would decrease to a mere 34 pounds. You would also be able to carry stuff 6 times heavier than what you can carry on Earth. It would be easier to walk on the moon's surface, but it would be more dangerous too. Your feet inside a heavy spacesuit would sink into the lunar soil up to 6 inches deep. But let's imagine you decided to skip the tedious process of walking by leaping through the air. Then you'd likely lose control of your jumps in no time. Plus, the moon's surface is littered with deep craters. It would be a tough feat to avoid all of them. Not so long ago, astronomers discovered a massive blob of some mysterious substance. It was hidden under the surface of the moon's far side. Its mass was the same as that of a pile of metal 5 times larger than the big island of Hawaii. The enigmatic something lies almost 200 miles beneath an enormous crater that appeared in the lunar surface billions of years ago. The blob likely has something to do with a super collision. It might be the metal core of the object that hit the moon back then. Scientists can't wait to lay their hands on the discovery. It could explain lots of things about the South Pole Aitken crater, the largest known in the solar system. If it was on Earth, its oval-shaped basin would stretch from Washington, D.C. to Texas. There's no air on Earth's natural satellite, but then how can it be rusting? Scientists have discovered the presence of hematite on the moon, and it's a kind of rust. A special NASA research instrument examined the light reflected off the moon's surface. It turned out that the composition of the satellite's poles was very different from the rest of it. The moon's surface is dotted with iron-rich rocks, but without oxygen and liquid water, rust can't appear. Solar winds add to the mystery. They bombard the moon with hydrogen, and hydrogen makes it much more difficult for hematite to form. But even though the moon doesn't have an atmosphere, it still has some trace amounts of oxygen. Its source is our planet's upper atmosphere. Earth also protects the moon from almost 100% of solar winds, although not all the time. And even though our natural satellite is bone dry, there might be water ice in the shadowed craters on its far side. The moon isn't a perfect sphere. It's shaped like an egg. Plus, the satellite's center of mass is a bit more than a mile off its geometric center. The Earth and the moon are gradually drifting apart, as slowly as your fingernails grow. This is the flip side of our satellite's gravitational force. The moon creates tides in the Earth's oceans. They pull back at the moon and make it speed up. This, in turn, moves the satellite to a higher orbit. In prehistoric times, the moon was way closer to our planet than it is now. Luckily, we aren't going to lose the moon. The farther away it moves, the weaker its gravitational pull becomes. It means that soon, our planet won't be pushing the moon away with such a force. There's very little activity going on inside the moon. Plus, there's almost no atmosphere around. That's why scientists can trace impact craters littering the satellite's surface back billions of years. While dating the craters, astronomers discovered that the moon, along with our planet, went through a late heavy bombardment about 4 billion years ago. This event is also known as the lunar cataclysm. This interval lasted several hundred millions of years. During it, an unusually large number of asteroids collided with Earth, Mercury, Mars, and Venus. There might be a labyrinth of lava tubes on the moon. Not long ago, astronomers received the results of an underground lunar topography. They discovered a massive cave under the satellite's surface, about 30 miles long and 60 miles wide. The cave's likely to be the result of 3 billion-year-old volcanic activity. After streams of lava hardened, they created a thick, hard crust on the outside. But inside, lava kept flowing, melting the rock and forming tunnels and caves. Countless pits in the moon's surface, discovered by NASA, might be the openings to lava tubes. The moon's orbit around the Earth isn't a circle, it's an oval. That's why the distance between our planet and the satellite varies from over 225,000 miles to more than 250,000 miles. There's very little seismic activity going on inside the moon. Yet, many moonquakes, caused by our planet's gravitational pull, sometimes happen several miles below the surface. After that, tiny cracks and fractures appear in the satellite's surface, and gases escape through them.
Look at this fascinating planet. It looks as if it's burning. It must be hotter on its surface than in the middle of Death Valley. The ground is parched, cut by giant cracks. There's not a drop of water in this boiling world. Now, it's the same planet, but it looks like a totally different place. Everything is frozen. The temperatures are so low, there isn't even a tiniest chance that life could survive on this planet. This bizarre world is called HD 20794d, and it's located 19.7 light-years away from Earth in the constellation Eridanus. This planet is a super-Earth. This term means that it is larger than Earth but smaller than such ice giants as Neptune. What makes this planet especially interesting is its unusual orbit, which moves it in and out of its star's habitable zone, the region where temperatures might allow liquid water to exist. Now, we haven't seen this unusual planet directly. Astronomers detected it by measuring tiny wobbles in its star using two powerful instruments, espresso and HARPS, located at telescopes in Chile. These instruments measure radial velocity, which is the small movement a star makes as a planet's gravity tugs on it. The larger the wobble, the more massive the planet. Later, astronomers analyzed the data and figured out that the planet in question has a mass around 6 times greater than Earth's. It orbits a star, which is slightly smaller and dimmer than our Sun. What makes this star unique is that it is bright enough to be seen with the unaided eye, unlike many other stars that host exoplanets. You won't be able to see them without a telescope. The star system has been observed for over 20 years. Astronomers have long suspected it had multiple planets. In 2011, scientists discovered 2 other super-Earths orbiting the star every 18.3 and 89.6 days, respectively. For some time, researchers thought they had found a third planet with an orbital period of 40 days. Later, they realized they had made a mistake. But recently, after reanalyzing years of data, astronomers have confirmed that the third planet does exist, and it's our extreme HD 20794d. A researcher from the University of Oxford played a key role in identifying the planet. He used a special computer algorithm called Yarara to separate the planet's weak signal from the background noise. It helped him confirm that the planet truly existed and was pretty unique. Unlike the planets in our solar system, which have mostly circular orbits, the newly discovered one follows a highly elliptical, stretched-out orbit. It takes 647 days to complete one trip around its star. That's just 40 days shorter than Mars's orbit around the Sun. At its furthest point, the planet is twice the Earth-Sun distance, which makes it an icy world far outside the habitable zone. At its closest point, it moves inward to 0.75 AU, where it enters the habitable zone, where liquid water might exist. This extreme movement creates truly bizarre seasons. For some part of its orbit, HD 20794d is frozen, like an icy wasteland. As it approaches its star, temperatures rise and ice likely melts, forming temporary oceans. The planet then experiences a short, scorching summer. It is so hot that the water on its surface might evaporate into the atmosphere. Shortly after, the planet moves away again. It triggers a gloomy fall with rains, followed by a deep freeze in winter. In other words, the planet switches between extreme cold and intense heat, which makes it a very unpredictable place for life. If any life forms exist there, they certainly need to adapt to dramatic changes in temperature and environment. Why does the planet follow such a mind-boggling orbit? It might be a leftover effect from events billions of years ago, when the planetary system was still forming. At some point, another large planet may have disturbed the orbit of our extraordinary friend. Another possible explanation is that a giant planet once existed in the system, and its gravity pushed HD 20794d into an elongated path. Later, this giant planet may have been ejected from the system, leaving the smaller planet in its current orbit. This theory makes sense because the 2 other planets in the system, B and C, have more normal circular orbits. The discovery of this planet is so exciting because it challenges what we know about habitable planets. Most planets in the habitable zone stay there permanently, but HD 20794d only passes through it. Scientists want to know if such a planet could still support life, even briefly. So future telescopes will study the atmosphere of this planet, looking for signs of water, gases, or even life. Another super-Earth that might have the right conditions for life orbits a star 137 light-years away. In space terms, this is considered relatively close. A light year is around 6 trillion miles. The planet is called TOI 715b, and it's about 1.5 times the size of Earth. Unlike HD 20794d, it's permanently located in the habitable zone. Look, that's what astronomers think the planet might look like. TOI 715b orbits its star very quickly, completing a full orbit in just 19 days. But even though it's close to its star, it may not be extremely hot, all because its star is a red dwarf. That's a type of star that is smaller and cooler than our Sun. This means TOI 715b could have a milder temperature compared to other exoplanets that orbit closer to hotter stars. NASA discovered the planet using the Transiting Exoplanet Survey satellite. This space telescope finds planets by watching for small dips in a star's brightness, which happen when a planet passes in front of it. Since red dwarfs are smaller and dimmer than the Sun, planets passing in front of them are easier to detect. Astronomers are planning to study the planet further using the James Webb Space Telescope. This powerful telescope, located 1 million miles away from Earth, can analyze the atmospheres of distant planets. If TOI 715b has an atmosphere, JWST could help scientists determine what gases are present in it and whether such conditions could support liquid water or even life. One more promising world for our search for extraterrestrial life is an extremely dense super-Earth in the K2360 system. An international team of researchers from Japan and Europe has discovered this remarkable multi-planet system orbiting a Sun-like star located 750 light-years away. This system has 2 planets, including one of the densest rocky planets ever found. The K2360b is a rocky super-Earth, about 1.6 times the size of Earth, but with a mass 7.7 times greater. This makes it as dense as lead. The planet orbits its star incredibly fast, completing one full orbit in just 21 hours. It's the densest known ultra-short period planet with well-measured properties. As for its sibling, this is a much larger outer planet with at least 15 Earth masses. It takes 9.8 days to orbit its star. Sadly, since it does not pass in front of its star from our viewpoint, scientists cannot determine its exact size. The unusually dense planet might be the core of a much larger planet. Over time, intense radiation from its parent star may have blown away its outer layers, leaving behind only its dense, rocky core. So, in fact, this planet could show us what might happen to some planets that are too close to their stars. Astronomers think that the planet may have moved inward over time due to interactions with its larger companion planet. One possibility is high eccentricity migration, where a planet's orbit becomes highly stretched out due to gravitational interactions before gradually becoming more circular near the star. Another theory is that the planet's spin and axial tilt can cause its orbit to become more circular. Such planets are rare, and finding one with a massive outer companion can help scientists refine their theories about how planets form and evolve in extreme environments. With its help, we might also understand how rocky planets evolve and what happens to planets that get too close to their stars. Under your feet, the moon is pulsing. You feel danger with every pore of your body. The lifeless satellite, or so you thought, stays still for a second before knocking you down to the ground with a powerful tremor. Is it a moonquake? For years, scientists believed the moon was completely inactive, but the newest evidence seems to suggest that this idea is totally wrong. Researchers from the University of Maryland have recently discovered 266 mysterious ridges on the far side of the moon. And these ridges likely point to recent geological activity. So, are we really talking moonquakes? Well, kind of. The ridges are located in volcanic regions that formed 3.2 to 3.6 billion years ago, but they appear much younger than expected. Typically found in clusters of 10 to 40, they're often located in areas where the moon's surface is structurally weaker. Now, when astronomers speak about recent, don't take their words literally. They don't mean last year or even decade. Most models scientists created suggested that the moon's geological activity ended 2.5 to 3 billion years ago. But the new information hints at the possibility that these formations have been active within the last billion years. Some of the smaller ridges seem to have formed as recently as 200 million years ago, and that is considered relatively young on the moon's timescale. It means that the moon may still be experiencing geological changes today. These discoveries kinda challenge our understanding of the moon's history and evolution. But how did scientists come to these conclusions anyway? Researchers from the University of Maryland and the Smithsonian Institution used crater counting to estimate the age of lunar ridges. It works like this. Surfaces with fewer craters are younger, and the more craters some region has, the older it is. Plus, the analysis showed that some ridges cut through already existing craters, meaning they likely formed around 160 million years ago. In geological terms, this is very recent, suggesting that these ridge-forming processes may still be happening. Another cool thing is that the ridges on both the near and far sides of the moon are similar, which means they may have formed through the same geological processes, having been shaped by the same forces. These forces might include the moon's gradual shrinking, thermal contraction, and shifts in its orbit. We'll talk about it a bit later. Another argument supporting the idea of a still active moon is decades-old data from the Apollo missions. They had already detected shallow moonquakes with the Apollo Lunar Seismic Experiment, recording 28 quakes ranging from magnitude 1.5 to 5. Researchers believe that these ridges may be linked to similar seismic activity. Now, about that bizarre shrinking of our natural satellite. Scientists believe the moon formed about 4.5 billion years ago when a Mars-sized object collided with early Earth. This catastrophic impact likely sent bunches of superheated material into space. Eventually, they came together and formed the moon. In its early years, the moon was just a molten world, shaking from intense volcanic and seismic activity. So, the moon used to be a molten mess floating through space. But when did it actually solidify? Scientists have finally figured it out, 4.43 billion years ago. This was a huge turning point, not just for the moon, but for Earth too. After all, the giant impact that formed the moon might have also been the final blow that made Earth stable enough to support life. In any case, billions of years passed. The moon gradually cooled and contracted. And now look at this modern-day rocky sphere illuminating our nights. But the moon isn't completely rigid yet. It still keeps cooling. And this slow cooling of its core might be one possible reason for the moon's continued activity. As it cools, the moon's interior contracts, which leads to cracks and shifts in the crust. One of the clearest signs of this contraction is found in the lunar maria. See these large, dark patches on the moon? Those are called maria, areas formed when lava filled ancient asteroid impact craters and then solidified. Then, over time, the cooling and contracting crust created these wrinkle ridges. Another factor of the ongoing geological activity could be the moon's gravitational interactions with Earth. Such non-stop powerful interactions likely create surface stress and trigger tectonic movements. It's all good and exciting, but can this activity on the moon actually affect humans? In a sense, it can. The moon has long been seen as a stable place for future bases and resource extraction. But the discovery of this ongoing geological activity is pretty worrying. If the surface is still shifting, future settlements, infrastructure, and mining operations could face serious risks. That's why, at the moment, we need seismometers and ground-penetrating radars to better understand these movements. It will allow us to assess potential dangers before any long-term missions begin. By the way, There's another potential problem future lunar missions might have to deal with, and it's moon dust, aka regolith. Apollo astronauts quickly learned that this jagged, sticky dust gets everywhere and can damage suits, equipment, and even health. A new study from Texas A&M engineers found another problem. When rockets land or take off, they kick up regolith, which can become a collision hazard, especially with many spacecraft bringing crews and cargo to the moon. Lunar regolith comes in all sizes, from tiny dust particles to large rocks. The main ingredient in moon dust is fine silicate materials, about 70 microns in size, like a human hair. They formed over billions of years as meteors and asteroids smashed into the moon's surface, grinding much of it into powder. Unlike Earth, the moon has almost no atmosphere. It's incredibly thin, so there's no wind or water to smooth out the dust. On top of that, constant exposure to solar wind has given the regolith an electrostatic charge, making it stick to anything it touches. Apollo astronauts quickly found this out the hard way. Moon dust clung to their suits, got trapped inside their landers, and stuck to everything. Worse, it became a health hazard, causing eye irritation and breathing problems inside their spacecraft. But at the moment, it seems like a problem for future us. A much more important issue is finding water to support future missions, and China is going to deal with it. It's getting ready for a big mission to look for hidden ice on the moon. As part of the Chang'e 7 mission in 2026, a flying robot will explore deep craters at the moon's south pole, where ice might be trapped. If they manage to confirm it, this could be a game changer for future lunar missions. Astronauts will have a water source and even fuel for space travel. The mission is a key step in China's plan to land astronauts on the moon within 5 years. While signs of water have been found before, like in soil samples from Chang'e 5's probe and observations by NASA and Indian spacecraft, scientists believe that deep ice deposits are the real key to supporting future missions. The south pole of the moon has some incredibly deep craters, and experts think ice could be hiding inside them. The flying robot will try to explore one or more of these craters after landing. If it does find the ice, it could make long-term moon missions much cheaper and more practical, helping astronauts live and work on the moon. Some scientists also think that this discovery could offer us some clues about extraterrestrial life. In any case, whether we find water on the moon and learn to deal with that pesky dust or not, the recent discovery of those young lunar ridges is a game changer. If the moon is still geologically active, it means we don't know as much about our closest neighbor as we thought. What else could the moon be hiding? Are we really prepared for the idea that this lifeless satellite might actually be more dynamic than we imagined? Future missions, which might not be as safe as we once believed, will probably show.
In the heart of the galaxy. Also, Sagittarius A star doesn't seem to have a very good appetite. It's been observed to be pretty quiet lately, which is good news for us. But even if it were super greedy, it wouldn't pose any threat to us. This black hole is over 26,000 light-years away. From Earth, we can see it in the Sagittarius constellation. In 2022, the Event Horizon Telescope collaboration released the first ever image of Sagittarius A star. It took years of collaboration and technology to capture this stunning image. And this is our second photo of a black hole in history. The first one was released in 2019, and it showed the supermassive black hole called M87 star. Yes, they both have star in their names. Don't try to make it make sense. Anyway, you may remember this photo as the first ever image of a black hole ever. It went crazy viral across the internet. And this black hole, M87 star, located in the Messier 87 galaxy, is way scarier than Sagittarius A star. You thought 4 million solar masses is impressive? Then how about 2.5 billion solar masses? M87 is a real monster. It's also known for its powerful jets of plasma, which are so energetic that they extend thousands of light years from the black hole's center. If M87 were a superhero, it would be Iron Man, with his repulsor beams on full blast. Now, technically, you can't take a photo of a black hole itself, since it's, well, black. No light can escape its grasp. But the glowing orange ring in this photo shows the matter surrounding Sagittarius A star. It's called the accretion disk, a swirling disk of hot gas that spirals the center, heating up to millions of degrees in the process. It's like a giant fiery vortex, but with no escape. And the shadow in the center indicates the black hole itself. Inside that shadow, there's an event horizon. The event horizon is the boundary around the black hole, beyond which nothing, not even light, can escape its gravitational pull. It's the point of no return, where the gravitational force is so strong that even the fastest object in the universe, light, can't escape. Once you cross the event horizon, you're doomed to fall toward the center of the black hole, where the laws of physics as we know them break down. And this is exactly the fate that awaits our unfortunate X7. Right now, the pure blob is getting stretched and yanked by powerful tidal forces. By the way, before it meets its untimely demise, X7 is expected to put on a bit of a show. Its closest approach to the black hole, called periastron, is projected to happen in 2036. And when it finally gets torn apart by the Sagittarius A star's gravitational forces, there may be some cool fireworks to see. But this is not the most important thing. The funny part is, X7's future end may help us finally understand what the heck even is this thing. A team of scientists have been studying how a strange blob orbits the black hole. And that's when they discovered that X7 has stretched to almost twice its initial length. And what does that mean? Well, it suggests that X7 is most likely made of debris ejected during a recent collision between two stars. Yep, you heard that right, a space car crash. Imagine this. Two stars fall in love and start circling each other for many years. After that, they finally merge together. At this moment, they eject tons of gas and dust. And perhaps this cosmic dance created our blob baby, X7. It's basically like the crumbs left on the table after a giant space feast. Something like this is actually pretty common, especially around black holes. It's like a galactic fender bender that sends debris flying everywhere. Actually, the universe is full of mystery blobs. They're called the G objects. No, they're not the G-men from Men in Black, but they're just as mysterious and elusive. These guys have been puzzling astronomers for more than 20 years. They look like gas clouds, but behave like stars. It's like they can't decide whether they want to be a cloud or a star. Come on, guys, make up your mind. G objects stretch out at the closest point to the central black hole, but emerge intact, like a rubber band that stretches but doesn't break. Scientists think that they're the stars that have merged together into one. And while doing that, they also produce a huge cloud of gas that hides the result from view. Kinda like when you're wearing a bulky sweater, so that no one knows that you've put on a few extra pounds. And then a study published in 2021 found that one of these objects, G2, was actually a molecular cloud concealing 3 baby stars. Talk about a plot twist. But X7 is the black sheep of the strange blob family. It's significantly different from the G objects, like the weird cousin you see once a year at family gatherings. Its evolution has been more dramatic. Also, it's not being held together by a mass lurking in its center. So what is it being held together by? Pixie dust? Magic? We need answers! That's why scientists believe that X7 isn't a G object itself, but debris left from it. Or maybe not. We have no idea. The possibilities are endless, and that's what makes astronomy so exciting. So let's keep our eyes on the skies and see what other strange objects are out there. Who knows? Maybe we'll discover another mystery blob, and this time It's going to be a spaceship. Now that would be awesome.
The planet races through space. Its orbit is unstable, like a pool ball gliding across the table looking for a target to collide into. Only this ball is the size of Mars, and it's going 9,000 miles per hour. Boom! It crashes into another planet. This Mars-sized object was called Theia, and what it smashed into was Earth. The impact released 100 million times more energy than the asteroid that wiped out the dinosaurs. The planetary collision threw tons of solid material from both objects out into space. But only one of the bodies survived. Theia was obliterated and then swallowed entirely by early Earth. But that debris didn't go flying endlessly into the cosmic void. No, something crucial happened. All those solid chunks gathered into a cloud. Gravity squished it together, pressing more and more. And in the end, our moon was born. So goes the theory. At the time of the impact, the solar system was just forming, and this rendezvous of epic proportions probably wouldn't have happened if it weren't for a newly formed Jupiter throwing Theia off its orbit and straight into Earth. Our young planet withstood the blow. Time passed, Earth evolved. Its surface will become unrecognizable over the next 4.5 billion years. It's hard for the human mind to understand this vast amount of time, so we'll squeeze it all into one day. If midnight is when Earth first formed from gas and dust that remained after the Sun's creation, the next 4 hours show a lifeless planet. Red hot, covered in lava, constantly bombarded by asteroids and, as you know by now, even a whole other planet. Yet life finds a way. The first cells appear. It's 4 a.m. on the clock. At 2:08 p.m., we see the first single-celled organisms form. It's not until 8:28 p.m. that sea plants appear. 20 minutes later, what's this? Jellyfish. After them, the planet flourishes with different fish, reptiles, insects. The forests grow at 10:30 p.m. Between 10:56 and 11:40, dinosaurs roamed the Earth. The giant lizards ruled our planet for less than 1 hour. A minute before the dinosaurs' extinction at 11:39 p.m., the first mammals begin to run around the planet. At 11:58 and 43 seconds, humans appear. In the cosmic scale of things, we've only ruled this planet for 1 minute and 17 seconds. So here's the main question baffling scientists. Why didn't life on Earth ever stop? It had every chance to cease. Why didn't our planet become like Venus or Mars? They both once had an atmosphere and oceans. Today, they're lifeless deserts. Forget about complex scientific concepts and theories of the universe's structure. Our little rock and all its inhabitants are just incredibly lucky. Professor Toby Tyrrell at the University of Southampton used computer programs and climate simulations to solve the puzzle of why asteroid collisions and ice ages didn't turn our little rock into a lifeless wasteland. The research team took not 10, 100, or 1,000 virtual planets similar to Earth. They used 100,000 for the experiment. And every single one of those 100,000 were simulated 100 times. They exposed these virtual planets to different phenomena. They were bombarded by asteroids, frozen, exposed to epic eruptions of supervolcanoes that blacken the skies and block the surface from the sun's rays. Just 9%, or 8,700 of them, were successful one time in 100 simulations. Of that group, 4,500 planets remain inhabited 10 times. Only on one planet out of 100,000, life didn't stop all 100 times. If life is a lottery, Earth got extremely lucky. In 2009, the unique Kepler telescope was launched into space. Its task? Search one patch of the night sky, or 150,000 stars, for rocky Earth-like planets. Over 9 years in service, it ended up surveying more than 500,000 stars. In all that time, with all those observations over nearly a decade, Kepler discovered 2,600 possible Earth-like planets. The weird thing is, most of them are a type you can't find in our own solar system. They're something between the size of Earth and Neptune. But back to the real Earth. If you go far from the city and look up at the sky, you'll see an ocean of stars. If you're lucky and it's a clear night, with an unaided eye, you could count a maximum of 2,500 points of light. Yet, there are at least 100 billion stars in the Milky Way. Some estimates put the numbers of stars in the Milky Way up to 400 billion. So, where's this giant range coming from? Well, counting stars isn't exactly an easy job. Scientists obviously don't number each one individually, 1, 2, 3, and so on. You know how long it takes to count just 1 billion? Over 100 years. Now, multiply that by 400. Instead, they look at small patches of space and use some complex scientific formulas to make educated guesses of how many stars there are in total. You can do a similar experiment yourself. Imagine a bucket filled with 10 pounds of rock, sand, soil, and other items. Your job? Understand how many rocks are in that mix. We'll count only those rocks that are visible to us from above. Get a rough estimate of their volume and weight, what percentage of the total we can see, and with some calculation, you can get a number. Is it exact? Nah. Why? Because you can't know if the rocks in the bucket are spread evenly throughout, or if they're all about the same size throughout. What if the ones at the bottom, if there are any, are bigger or smaller than your sample view? They could have completely different weights and volumes. That bucket is our Milky Way galaxy, and the rocks you are counting are stars. The point? Scientists can't know for sure how many stars there really are. Maybe 100 billion, or perhaps 4 times that. Of those, 4 billion are like our Sun. With our own galaxy, the most accepted estimate for planets that could potentially support life is 300 million. Though, as the tradition of scientific inexactness goes, that number could be up to 5 billion or more. Either way, lots of real estate to choose from. And that's just the Milky Way. But get this, it's just one of 200 billion galaxies in the observable universe. The most recent research puts that number 10 times higher, something like trillions of galaxies in space. And we've only studied less than 10% of them. As for how many stars there are in the universe, scientists put it at 1 septillion. That's 1 followed by 24 zeros. Again, it's all estimates because we can't know for sure. So far, one thing is clear. Our Earth is the only place in the universe that we know of where there's life. And this planet has done everything it can to change that. Over the past 540 million years, more than 20 major extinction events have occurred. The last one was 66 million years ago. Yep, it was the one that took out the dinosaurs, and 75% of all life on this planet for that matter. An object 7 miles across in diameter smashed into our planet. It was going 120 times faster than the fastest car today. Over 900,000 miles all around the impact site, everything caught fire. A huge tsunami swept across the world's oceans. Billions of tons of dust and sulfur rose into the sky and blocked the sun's warm rays. A global cooling came to Earth. A little over 200 million years ago, there was a lesser-known extinction event that wiped out half of all life on the planet. Most likely volcanoes or an asteroid strike are to blame. Other theories say the movement of tectonic plates triggered another ice age. At that time, huge crocodiles ruled the Earth. They disappeared and new animals entered the arena of history, dinosaurs. But the worst this planet has ever seen was the Permian-Triassic event about 250 million years ago. 80% of marine life, 70% of land animals and plants, all gone. Volcanoes spewed out a colossal amount of lava where modern-day Siberia is, but it affected the entire planet. Around 445 million years ago, the dominant life form on our planet was marine invertebrates. There was only one continent, Gondwana, and plants were just starting to flourish on land. But something happened that took out 75 to 85% of all living organisms. It could have been an ice age, rising temperatures, or a more daring theory. Some think it could have been a huge star exploding 6,000 light-years from Earth. It launched a jet-like gamma-ray burst that ripped across space, and poor little Earth happened to be in its path. It burned off the ozone layer instantly. Yeah, we kinda need that thing to protect us. Case in point, no matter how much this planet, or even the universe, tries to wipe out life on Earth, which is here in the first place from unbelievable odds, life always finds a way. The search for ET is on. It's most definitely on. With the successful launch of the James Webb Telescope, the search for Earth-like planets has become a riveting topic of worldwide attention. Apart from the James Webb Telescope, other tools are being used to find good Earth-like candidates. The TESS satellite and the Kepler telescope are at the forefront of searching for other Earths. After we first clear the air of a few pesky philosophical questions, we'll take a close look at these two searches and what the James Webb Telescope hopes to find. So, why are we searching for Earth-like planets? Well, because we can. Incredible advances in Earth-bound telescope technology have enabled ultra-precise observations of starlight, which led to the earliest discovery of exoplanets. As planets go around stars, there's a gravitational interaction between the planet and the star. They pull each other. The planet's pull upon the star will cause the starlight to wobble back and forth ever so slightly as the planet or planets orbit the star. This has always been the case, but the wobble of the starlight was never able to be detected because starlight always twinkles. You know, twinkle, twinkle, etc. Adaptive optics inside telescopes is the technological breakthrough that first enabled astronomers to find exoplanets by taking the twinkle out of starlight. Mechanical springs on the underside of telescope mirrors bend the mirrors ever so slightly to neutralize the distortion, the twinkle, caused by starlight passing through Earth's atmosphere. Without the glimmer of starlight, the slight wobble caused by planets pulling gravitationally on the stars is observable. The bigger the wobble, the more planets. It's called the astrometric method of exoplanet detection. Isn't that a mouthful? Whole star systems and literally thousands of exoplanets were inferred to exist around nearby stars by analyzing the wobbly patterns of starlight. But the planets themselves could not be seen. Suddenly, our solar system was not unique anymore. Astronomers got giddy over the inescapable conclusion that probably every star had planets. It became impossible not to ask the poignant question, is the Earth unique, or are there other Earths? What's the big deal about finding Earth-like planets anyways? Well, considering all the financial resources the developed countries are spending on finding Earth-like planets, it can be said without a doubt that it's definitely a big deal. Including the launched James Webb Telescope, which cost $10 billion, the Kepler Space Telescope, which cost $550 million, and the TESS satellite, which cost $200 million. The investment in finding Earth-like planets is certainly eyebrow-raising. Now, if you keep in mind that these costs are just for the hardware, and to get a sketch of the full magnitude of the search, you must also include the salaries of a team of data miners, PhD analysts, and postgrads all across the globe in universities, national space agencies, and private institutions. We will conclude that finding another Earth is truly an immense undertaking. Now, suppose we find one. Then Earth is not alone anymore. It's not that we can actually go to any of these planets anytime soon. Interstellar travel requires some breakthroughs in physics and technology, and, well, we aren't there yet. But knowing that there are planets out there in the Milky Way that are like Earth in all the essential respects, like liquid water, oxygen, and habitability, will make space less foreboding, more welcoming, more exciting to study and explore. It may also give us some more pride in our home planet and make us all better Earthlings. The triple mission looking for other Earths, the Kepler telescope, the TESS satellite, and the James Webb telescope use distinct approaches to find exoplanets. And the synonym TESS tells us what that method is. The T stands for transiting, and that's the key to the whole exoplanet search. E stands for, you guessed it, exoplanets, the target of the excellent investigation of another Earth. S stands for survey, because TESS looks at hundreds of thousands of nearby stars. And S stands for satellite, because TESS is orbiting Earth, unlike the James Webb Space Telescope, which will orbit the Sun. When a planet passes in front of a star, that is called a transit. The planet will block some of the light coming from the star. This decrease or dimming of the star can be measured. The dimming of starlight tells lots of things about the planet. By knowing how bright the star is and how much the star's light was dimmed by a transition in front of the star, we can tell how giant the planet is or how close it is, but we won't know which. Is it big or is it close? Until the planet's orbit is also timed. It means our test satellite must take long-duration videos of the stars. Ooh, video of the stars. Hollywood should like that. The test satellite doesn't have a telescope. It uses 4 CCD cameras to stream live long-duration videos of as many stars as possible, hundreds of thousands of stars. Why so many? Well, because for a transit of a planet to be observed, it must pass directly between the test satellite's cameras and the star. If the planet is not on the exact line-of-sight angle between the star and TESS's cameras, it cannot be seen because it will not cut off any starlights. Planetary transits are rare. For example, Venus passes across Earth's view of the Sun only every couple hundred years, yet TESS's cameras are seeing many planetary transits among the hundreds of thousands of stars it takes streaming long-duration videos of, and you know what that means. It means there must be hundreds or thousands of times more planets than are observed by the transiting method. It is, therefore, an inescapable conclusion that every star has planets. Planets are everywhere. And now, the James Webb Space Telescope, with its giant 21-foot 4-inch wide mirror, is entering the search. It is a technological marvel, a wonder of the modern world, a miracle of advanced engineering. Anticipation is reaching a fever pitch. But with the heightened anticipation comes an almost equal amount of trepidation. And some things can still go wrong before the James Webb Space Telescope returns its first pictures. After the Hubble Space Telescope, for example, was launched in 1990, a repair mission had to be launched in 1993. The mirror on the Hubble was not very well inspected, and its pictures were very blurry. Astronauts had to go up and execute a spectacular spacewalk to fix the mirror. After the fix, the pictures Hubble sent back were more precise than it was ever designed for. This is how an improved model appeared. That cannot happen with the James Webb Telescope. The Hubble orbits the Earth and is accessible to astronauts. The James Webb Space Telescope orbits the Sun and is well beyond the Moon, out of the reach of astronauts, because there is no spacecraft equipped to carry him there. It cannot be manually fixed if something goes wrong. Adding to the challenges, the James Webb Space Telescope has only one onboard camera to inspect any damage it may suffer or mechanical malfunctions that might develop in the harsh environment of interplanetary space. Any remote fixes will need to be done blind from Earth. The James Webb Space Telescope is now fully deployed. The 18 mirror segments will need to be aligned to produce a single image. This critically important process will take several months to complete once the telescope is fully deployed. 70 of the first 286 observation assignments of the telescope target exoplanets. Using data from previous exoplanet searches, it will not have to waste time searching for exoplanets. Their locations and orbits are already known. The James Webb Telescope will go right after them. The James Webb Space Telescope is not an optical telescope in the same sense as the Hubble Space Telescope or any ordinary telescope that sees visible light. It sees infrared light. The pictures of planets are expected to be bright dots, somewhat fuzzy if they have atmospheres. The spectra of the planets will yield the most information about the exoplanet. Any gases around an exoplanet will absorb some starlight as the starlight passes through the planet's atmospheres. Suppose there is methane in the planet's atmosphere, oxygen, or carbon dioxide, the gases that most indicate life. In that case, the James Webb Telescope will be able to pick them up by spectroscopic analysis. An entire portrait of the exoplanet can be formed from the infrared information. its temperature ranges, atmospheric content, the likelihood of liquid water, and even the probability of life. And that's a big deal. The James Webb Space Telescope has other missions to perform too. It's assigned to examine star formation and planet formation in nebula in the Milky Way. Understanding how solar systems form is part of the search for another Earth. By detecting infrared light, the James Webb Space Telescope will peer to the farthest away galaxies whose visible light gets blocked by dust and gas. These distant galaxies were formed shortly after the Big Bang. Galaxy formation is an essential mission for the James Webb Telescope. These most distant galaxies are accelerating away so fast that the light they emit is stretched below the frequency of the visible spectrum, into the infrared. The Great Telescope can see these previously invisible galaxies. We hope to learn about the mysterious dark energy that is causing the universe to expand at an ever-increasing velocity. Hope is high that the James Webb Space Telescope will significantly expand our knowledge of this amazing universe we all live in.
This is Neptune. The next stop is Pluto. Stand clear of the closing doors, please. One day, with top-notch future technologies, one stop from Neptune to Pluto won't seem much further than Times Square from Bryant Park today. There are huge ice mountains on Pluto, valleys that go further than your eyes can see, 160-mile large craters, almost as big as the largest one on Earth, and no life. The reasons are obvious. The long distance between Pluto and the Sun guarantees freezing temperatures on that dwarf planet. It also ensures a trip of a few billion miles. Plus, it's smaller than the Moon, so it would get crowded very soon if people started dwelling there. Still, there's one reason which makes life there not that far-fetched. The Sun has a lifespan and cycles within it. Our solar system used to be nothing but a cloud of gas and dust. As a result of a gravitational collapse at the center of this cloud, the gas and dust started gathering in specific, denser places. These pulled more and more matter as time went on, and something called conservation momentum made the mass start rotating and heating up because of immense pressure. Later, there appeared a disk similar to what Saturn has, but it was made of entirely different substances. And right in the center, there was the ball that eventually became the Sun. A protostar is a young star that's still gathering its mass, and that's exactly what the Sun was before the temperatures and pressures inside of it lighted up its core. Millions of years later, it became the Sun we see every day. But it won't stay this way forever. It will heat up even more and eventually get bigger and denser, turning into a red giant. It may one day get big enough to swallow up Venus and Mercury. Chances are, it might swallow even planet Earth. Even if it doesn't devour our planet, the Sun might get close enough to touch us. Well, if this happened, life on Earth wouldn't be possible. But then, in just a few minutes, the Sun loses about 40% of its mass and shrinks about 10 times what it used to be. It's not as bright, and indeed, not as hot as it used to be. By this moment, Earth will have already been deserted. People might want to start traveling around space, or settle down on another planet where life is sustainable, like the exoplanet Kepler-62f, which, by the way, is even bigger than Earth. While all of this was happening, Pluto was changing. Before, every resource was frozen inside of the dwarf planet. Water, gases like methane, carbon monoxide, you name it. But as the Sun was reaching its peak luminosity, Pluto was slowly warming up and losing a lot of what it had to the vastness of space. At the same time, an atmosphere formed up. If the atmosphere gets thick enough, it would create favorable life conditions. Then, instead of spaceships, a tiny percentage of us would be able to set up colonies on the dwarf planet. The temperature is comfortable there, almost t-shirt weather. It even resembles Earth a tiny bit. Canyons filled with water, beautiful endless fields with trees, and lots of space to run around, and mineral water pockets on the ground, good enough to drink. Pluto's rotations are different than Earth's. An Earth day is 24 hours, and sometimes it still feels like it never ends. But on Pluto, a whole rotation around the Sun takes 153 hours, because it's pretty far away from the Sun. After several hours without sleep, we get tired and our eyes get red. It means we'd have to take several naps throughout the day on Pluto. A year on Pluto equals 248 Earth years. Unless we come up with some sort of technology to get us to live that long, our entire lifespan would be less than half a year on the dwarf planet. So, houses on Pluto might need to be equipped with cryo chambers. Whenever you feel like dreaming for a long time, you jump in it and wake up 50 Pluto days later. On the dwarf planet, there are also seas and beaches, so it's just like a tiny Earth, far away from the actual Earth. The food on Pluto could be tastier. We might find a way to make the ingredients more savory and even try to grow them faster during the trip. You plant a carrot, and 2 days later, it's ready to be in your salad. There could also be new ingredients for our salads on Pluto. Maybe 2-meter-tall mushrooms we've never seen before. The animals we would take with us on the trip would get released into their new home forever. And with time, they would evolve and adapt to their new environments. The law of the jungle could change a bit too. Lions might not be kings anymore. Deer are. Their antlers are twice the size of what they used to be. But to be fair, so are the deer. Most of the animals that were already here used to live underwater. But with time, the amphibians started shifting to the surface, just like Earth at the beginning of life. Pluto could only be a temporary home though. Once the sun has finally reached its final phase, Pluto would get frozen and lifeless again. People instead would need to try to find a planet that stays in the Goldilocks zone of another galaxy. The Goldilocks zone is the exact proper distance from the star like the sun, where the temperature is perfect for the water to stay liquid. It's the rule scientists search for when looking for other planets that can sustain life. We can try setting new colonies on one such planet, or even try to set up our own artificial home, not exactly a planet or a spaceship, but a combination of both. Something huge built right in space, say a wheel with gravity everywhere we go, so we don't fall off. It would float in space toward the new exoplanet, capable of fitting entire states in. This whole trip might happen just because the sun first grew too much, and then, having reached the culmination of its life cycle, it would finally become a white dwarf. It's going to be a pretty long journey, and entire generations will be born here. You'll have a choice: sleep your way through the journey until humans finally reach their new exoplanet, or enjoy the trip in this fantastic spaceship. There's all you need on board: malls bigger than those on Earth, large futuristic cities, even places to farm, fields with rich soil made artificially, and finally, after a long journey, the exoplanet. It's even somewhat better than Earth. The planet is giant and has more continents. The continent's center isn't as far from oceans, which means there aren't as many desert areas. Though the sun of this planet is an orange dwarf, it's not as hot as our yellow dwarf sun today. It's a bit smaller, but here's the kick: orange dwarfs live somewhat longer. They remain stable for between 15 billion and 45 billion years. Despite that, this new planet is full of rainforests because the planet itself is warmer. It means more biodiversity and creatures we've never seen before. But even if nothing out there is suitable, we could try and terraform this planet instead. If we take Mars as an example, we could create a greenhouse effect by smashing ice-rich comets and releasing ammonia in them, making the planet warmer. We could also start planting trees. We'd probably need some Earth soil to do that, or we'd have to modify Mars's soil to be similar to ours. Sooner rather than later, the atmosphere would be close to the one we have on Earth. We'd be able to breathe too, because of the trees. Then, we can melt Mars's polar ice caps and voila, water. The problem is the solar winds and sun explosions that might strip it of an atmosphere just as quickly as we can create one, if not faster. It has no magnetosphere either, which means it can't protect us from radiation, so long-term Mars wouldn't be a good choice. Maybe out there, in the vastness that is space, there is a perfect planet waiting for us. We'll start with one of the most recent and shocking discoveries of 2020. Perhaps our solar system has life beyond Earth. This is Venus, the second planet from the Sun and the sister of our home planet. It's called so because it has a similar size and mass, but the conditions on it are simply terrible. The temperature on its surface reaches 890 degrees Fahrenheit because of the greenhouse effect, and the atmospheric pressure on it is as strong as if you were 3,000 feet underwater. But in this hostile world, there can actually be life. For many years, there have been discussions on this subject. In 2007, scientists discovered there once had been an ocean on Venus. That is, in the distant past, there could have been some form of life. But in the fall of 2020, there was an epic argument in which scientists tried to find out whether life on Venus exists right now. In September, the discovery of a new life marker on Venus was announced. The ALMA telescope in the Atacama Desert found phosphine gas above the planet, and the amount of this gas suggested that it may have been produced by certain microorganisms. But already in October, the data was analyzed again, and the new results indicate it was an error. So today, we consider Venus to be uninhabited once more. But who knows? Maybe soon we'll get new data, and new disputes will arise in scientific circles. And while some scientists are scratching their heads and still concentrating on Venus, others have looked into distant space and discovered 24 planets on which life can exist. And on all of them, living conditions are much better than on Earth. Such planets are called superhabitable. These superplanets must be 1.3 times larger than the Earth and twice as massive. Thus, they will have stronger gravity and, as a consequence, a denser and warmer atmosphere. So, the climate on superhabitable planets must be similar to the tropical climate on Earth. This will ensure the maximum diversity of living organisms. The host star of such a planet must be a red dwarf. They're much smaller than the Sun and not so bright, but their lifespan can reach 70 billion years. For comparison, the lifespan of the Sun is 7 times shorter, and it's already past half of it. Slow and steady wins the race. It will give enough time for potential life to develop and evolve. And here's a suitable planet for the title of superhabitable, Kepler 1649c. In 2020, it was named the most similar planet to Earth. It's only 6% larger than our home world. It orbits a red dwarf, a quarter the size of our Sun. The planet is in the habitable zone of the star and makes a complete circle around it in 19.5 days. The climate on Kepler remains a mystery. It's known to receive about 75% of the light we get from the Sun. So the temperature on its surface may be close to Earth's, but we still don't know the composition of the atmosphere and other necessary conditions for life to appear there. The next discovery is one of the most amazing spectacles ever seen by humanity. It's the collision of a star with a black hole. In September 2019, scientists began watching how, for 6 months, a Sun-like star was being spaghettified. Light from this event traveled 215 million light-years, and we saw a star about 860,000 miles wide slurped up by a black hole. This black disk is so heavy that it has incredibly strong gravity. Nothing can leave its gravitational field. And now we see a star slowly approaching it. First, the glowing light layers of the star begin to stretch towards the black hole. It looks as if the star is simply unrolling like a ball of thread. Then we see this hot plasma lingering at the edges of the black hole. And it may seem these particles are now orbiting it, but it's just an illusion. This ring of light is called the event horizon. The black hole curves not only space, but time as well. This close to it, time slows down. To the observer, it looks as if the light near the edge of the black disk has almost stopped. But in fact, it has long been absorbed by the dark abyss. When a black hole eats a certain amount of star material, it starts spitting it out. Powerful beams of energy are ejected at speeds of over 6,000 miles per second. This is the light that attracted scientists' attention. In the end, the black hole has completely absorbed about half of the star and spit out the other half into space. And even though we watched this process for only a couple of minutes, it was happening for 6 months. And here is one of the youngest planetary systems that humanity has ever observed, AU Microscopii. It's so young, there's still a disk around it from the debris this system was made of. But this time, we don't even hope to find life here. the host star of this exoplanet continually emits radiation flares that would wipe out any form of life from the planet's surface. The planet that orbits this dangerous star is called AU-MIC-B, and it's just a newborn baby by astronomical standards. It's so close to its star that it makes a complete circle around it in 8.5 days. The age of this planet is only 12 million years, so at the time AU-MIC-B was born, mastodons walked on the surface of our planet, and meadows and savannas were covering the Earth's face. So you and I can consider ourselves old-timers, because the age of the Earth is almost 4.5 billion years. The next discovery took place in early 2020, and it's very similar to a landscape from science fiction. It's a planet with 2 suns. Well, more precisely, it doesn't orbit around a single star, as we are used to in our solar system, but around a binary star system, TOI 1338. The first big star is like the Sun. The other is a red dwarf, which is 3 times smaller. These stars completely circle each other in a little over 14 days. The planet that orbits these stars is the size of Saturn, which is much larger than the Earth. Although the sunsets and sunrises there look incredibly beautiful, this planet is unlikely to be suitable for any form of life. It's outside the habitable zone of its host stars, so it probably doesn't have liquid water. Mysterious radio signals from outer space have also been received in 2020. We're talking about fast radio bursts. Scientists recorded such signals before, but recently they have managed to prove that they are repeated after a certain period of time. The new data have forced the scientists to come up with a very bold theory that their source may be a magnetar. A magnetar is a neutron star that is small and has a huge mass compared to ordinary stars like the Sun. But they have the strongest magnetic field in the entire universe. Their lifetime is very short though, only 1 million years. But what baffled scientists the most this year was discovering that the moon is rusting. Corrosion needs oxygen and water to take place, but the moon doesn't have its own atmosphere to have both. The main theory says the solar wind is to blame. It moves at great speed and scrapes oxygen from the upper layers of the Earth's atmosphere. The wind continues to carry oxygen molecules through space, and eventually they reach the surface of the moon and cause metal ore to rust. By the way, the signature red color of Mars was created because of the rust. For a long time, there was an atmosphere and water. In combination with iron on its surface, it triggered a long process of rusting, which has lasted since ancient times. Another stunning discovery was found on the surface of the moon with a stratospheric telescope. It's an aircraft that carries a telescope. The plane raises it to an altitude of 8 miles, and this allows it to have a picture quality comparable to that of space telescopes. And with the help of such an unusual observatory, scientists were able to find water on the surface of the moon. Water molecules were found in one of the largest craters on the visible side of the satellite, but the number of water molecules is still extremely small there. The Sahara Desert has about 100 times more water than the surface of the moon.
NASA sent a spacecraft right into the Sun. It's the fastest human-made object ever, and could cover the distance from Philadelphia to Washington, D.C. in just 1 second. The Parker Solar Probe's mission is to study our star's dangerous behavior. Scientists warn that massive solar storms are inevitable, and the consequences could be catastrophic for our planet. The spacecraft got 7 times closer to the Sun than any other probe ever did. It managed to do so during its 20-second flyby to the star since its launch in 2018. Because our star is so massive, its gravity is really strong, like a giant magnet. As the probe flies around the Sun, it uses gravity to go faster and faster and eventually picks up that crazy speed. As it got closer and closer to the sun's corona, which is its outer atmosphere, the probe had to survive temperatures of 2,552 degrees Fahrenheit. That's hot enough to melt many metals. It was protected from that heat and radiation by a 4.5-inch thick carbon shield. It kept the tools inside the probe safe and running at around room temperature. The scientists went to all this effort because they're hoping to solve a big mystery about the sun that's been puzzling them for ages. The surface of our main star is already super hot, but as you move closer out to the corona, the temperature shoots up to millions of degrees. And it doesn't make any sense because it's farther away from the sun. So maybe we could finally get some answers about this heat phenomenon. The mission is also going to help us understand something called solar wind. The sun is constantly shooting out tiny bits of energy and charged particles into space, like a never-ending breeze of electricity. When this solar wind hits Earth, it can create amazing light shows in the sky called auroras. The more active the sun is, the farther south you can see auroras. Our star follows natural cycles that last about 11 years. The activity goes from low to high and back down to low. Right now, we're in the solar maximum, the peak of the activity cycle. That's why we've spotted beautiful auroras in the most unexpected places in 2024. The downside to it is that the sun's activity can send out bursts of energy and charged particles that can mess up things like radios, satellites, and even GPS. It can be dangerous, especially for astronauts out in space who aren't as protected as we are here on Earth. Humans wouldn't feel the compression of the planet's electromagnetic field because of all the extra radiation, but power grids are really sensitive to it. If we don't act fast, when it happens, the influx of energy will go into power transformers all over the world, disrupt them, and leave big areas without electricity. If this happens during a hurricane or a tornado, when communication is already super important, it could make it much harder for emergency services to communicate and save lives. That's why it's so important to learn to predict this space weather. It's tricky because, unlike most disasters, like earthquakes, floods, and volcanoes, it doesn't leave behind any kind of physical evidence. The only big solar storms we really know about happened in 1859 and 1921. The first one, called the Carrington event, was so wild that it made sparks fly from telegraph wires. The auroras were seen all the way near the equator. Scientists back then were using a special kind of paper that reacted to light to record solar activity. During the Carrington event, the reading from the sun went off the page, literally. Whatever was happening, it was so extreme that we still don't fully understand it. Then, there was the New York Railroad Storm of 1921. It was powerful enough to knock out telegraph systems across the US, Europe, and the Southern Hemisphere. The storm boosted radio transmissions for a bit, making them travel farther than usual. But back then, there weren't nearly as many radios, so it wasn't super helpful. The bigger problem was the electrical grid in the US, which was heavily damaged. Back in 1859 and 1921, people weren't as dependent on tech as we are now. If a storm like that hits today, the consequences could be way more catastrophic. Scientists from New Zealand who study space weather are working on simulations trying to prevent disasters from happening. They say one of the possible options to do it is to study other suns like ours elsewhere in space. If we get data from thousands of stars, not just one, the picture for analysis would be more complete. So far, scientists have launched or plan to launch several other missions in addition to the Parker Solar Probe. Meanwhile, NASA is working on another mission, launching Endurance, robotic moon machinery on steroids. Its main mission will be to collect samples from key lunar locations that will later be retrieved by astronauts from the Artemis program. These samples are spread across the largest impact basin on the moon, separated by hundreds of miles. To do it, Endurance will have to be way more advanced than Perseverance, NASA's current most cutting-edge rover. Endurance will drive roughly 100 times further, drive 10 times faster, and collect roughly 200 times more sample mass. Endurance would also be the first planetary rover to drive at night. And because it will be on the far side of the Moon with limited communication to Earth and surface data, it will have to drive autonomously between sample locks and make its own decisions in tough conditions. When it reaches its destination, it's going to switch to a more classic way of doing things. Scientists back on Earth will get involved directly, guiding the rover to explore the sites and collect samples. The teams on Earth will also keep an eye on how the rover is doing by monitoring its telemetry, which is the data it sends back, like its health stats. If they spot any signs that a part is wearing out or something isn't working quite right, they'll tweak the plan to keep things running smoothly. All this will cost huge amounts of money, probably way more than the Viper moon mission that was cancelled after NASA had spent around $450 million on it. While Endurance is in the planning stage, the Blue Ghost lunar lander is already on its way to the Moon. Its main mission is research. It will spend 25 days in Earth's orbit, taking measurements and waiting for the right time to fling itself to the Moon. After 4 days in transit, Blue Ghost will hang out in lunar orbit for another 16 days to collect more data. Then it will descend to one of the largest basins on the Moon and spend 1 lunar day there. It will measure subsurface thermal data, radiation levels, and other important data. At the end of its mission, Blue Ghost will take some final pictures of the lunar sunset. It isn't designed to return back to our planet, so when the night falls, it will do some final work and go offline for good. NASA chose the team of University of Florida aerospace engineers to work on another innovative space project. It will cost $12 million, and its goal will be to improve the way we track changes in tectonic plates and oceans on Earth from space. It will use state-of-the-art sensors that will measure even the tiniest gravitational changes. The data it gets will help scientists monitor droughts, assess groundwater reserves, and better understand changes in sea levels. They expect to launch it around 2027 aboard a SpaceX Falcon 9 rocket.
So hey, take a look. This is our planet's crust, its outermost and thinnest layer. And here's the mantle, it's way thicker. And this is the core. Wait, what's happening here? Uh-oh, the core is leaking right into the mantle. Quickly, we gotta stop the leak. What do you mean it's been going on for millennia? Earth's core is actually a very intriguing thing overall. Its unique properties, ranging from housing a mysterious metal orb to being nearly as hot as the sun's surface. Well, another one on this list of enigmas, apparently, our planet's core is leaking gas. I can relate. Is it dangerous for us? Is it going to boom if somebody lights a match? Well, not really, all because this gas is a rare isotope called helium-3. Helium-3 is a version of helium with 1 neutron instead of the usual 2. Most of helium-3 in the universe was created around the time of the Big Bang, so it's some pretty ancient stuff. As the solar system formed, this gas became trapped deep within Earth's core. Shielded from space collisions and other cosmic hullabaloo, it remained hidden in the planet's depths for billions of years. Now, we've known for quite some time that occasionally, trace amounts of helium-3 escape to the surface, but no one has known the exact mechanism behind this leakage. Until recently, the breakthrough came with the discovery of exceptionally high ratios of helium-3 and its more common counterpart helium-4 in ancient lava flows on Baffin Island. This island is located in Canada's remote Arctic archipelago. The craziest thing is that these findings have the highest helium-3 ratios ever observed on dry land. The research revealed significant helium-3 levels. It might mean that the volatile elements from the solar nebula, that's the cloud of gas and dust that gave birth to our solar system, have remained in Earth's mantle since the earliest stages of the planet's formation. The discovery was made in lava flows that erupted around 60 million years ago, during the formation of a new seafloor when Greenland and North America split apart. But hey, it was amicable. The research team, led by Forrest Horton from the Woods Hole Oceanographic Institution, used advanced techniques to measure the helium trapped in olivine crystals within the rocks. These crystals formed before the magma erupted, which helped preserve the helium as it rose from deep inside the planet. The scientists found about 10 million helium-3 atoms per gram of olivine. That's a shockingly high concentration for Earth. You see, Earth's core acts as a reservoir for helium-3, storing it since the planet's formation. Over time, small amounts of this gas escape into the mantle through processes like mantle convection. That's when the planet's rocky interior stirs and moves like boiling water. Magma plumes, which appear in the mantle and rise to the surface, carry helium-3 with them. When the magma erupts, most of the helium escapes into the atmosphere. However, some of it gets trapped in crystals within the lava. That's how scientists can later study its origin and movement. Now let's follow the journey of helium-3 in the Baffin Island rocks. It began at least 100 million years ago. Mantle plumes carrying the helium likely took tens of millions of years to reach the surface. It means helium-3 has been leaking from Earth's core for millennia. It also means that our planet most likely formed in a solar nebula containing helium-3 and other noble gases. Baffin Island is an ideal location for studying Earth's deep interior. Its volcanic rocks are remnants of ancient lava flows that erupted when the North Atlantic began to open. The researchers traveled by helicopter to the remote island, which boasts towering cliffs, icebergs, and even polar bears. Local organizations helped the team access the area and ensured their safety during the expedition. The discovery of helium-3 leaking from the core raises new questions about what other elements might be stored deep within Earth. Could it be significant amounts of other light elements, such as carbon and hydrogen? These elements are critical for life and could provide further insights into the planet's habitability and evolution. For instance, the core's lighter-than-expected density might be explained by the presence of these elements. Plus, understanding the movement of helium-3 could also help track the behavior of other gases across the core mantle boundary. But this isn't the only unexpected discovery about Earth's insides. Let's go to Turkey's Central Anatolian Plateau. There, Earth's crust seems to be slowly dripping into the planet's interior. This process, known as lithospheric dripping, is still shaping the surface geology of the region. Lithospheric dripping occurs when the lower part of Earth's crust, heated to a certain temperature, becomes viscous and begins to flow downward. Imagine a thick liquid like honey or syrup flowing into a bowl. Now you get it. Now, speaking of Earth, it's been happening over a long period of time. And as this material moves downward, it pulls the crust with it, causing the surface to sink. As a result, we see new depressions or basins. Once this gooey material detaches from the crust and sinks further into the mantle, the surface rebounds, causing the ground to rise. This cycle of sinking and rising is what creates the shifting landscape in regions like the Konya Basin in the Central Anatolian Plateau. It is the very site where geophysicists observe signs of lithospheric dripping. The research team, led by Julia Anderson from the University of Toronto, first noticed unusual patterns in satellite data, including a circular feature in the region where the ground was sinking. After examining geophysical data beneath the surface, the team identified a seismic anomaly in the upper mantle and discovered a thickened crust beneath the Konya Basin. All this points to the presence of dense material, like a result of lithospheric dripping. The team's model suggests that the Konya Basin is currently in the later stages of this process. While the surrounding Central Anatolian Plateau has been uplifting over the past 10 million years, the Konya Basin is sinking at a rate of about an inch per year. While this number might seem small, it is quite significant in a region that is otherwise rising. Earlier studies have shown that the Central Anatolian Plateau has risen for around a half mile over the last 10 million years. It likely happened due to lithospheric dripping. However, the discovery of the Konya Basin reveals that this process is not one time, but can occur multiple times in different regions. The initial drip that formed the central Anatolian plateau likely caused daughter events, which led to the formation of the Konya Basin. To validate their model, the researchers conducted a cool lab experiment. It simulated the lithospheric drip process. So they took a tank filled with a highly viscous silicone polymer, which acted as a proxy for Earth's lower mantle. They also used a mixture of modeling clay for the upper mantle and ceramic spheres and silica sand to simulate the crust. A dense seed was inserted into the upper mantle layer to initiate the drip. Over the next few days, the researchers observed that the drip descended slowly. Within 10 hours, it began to fall. By 50 hours, a secondary drip had started. The results confirmed that, even without horizontal movement in the crust, the dripping process caused the surface to sink, forming a depression similar to the Konya Basin. This experiment has shown that lithospheric dripping can cause vertical deformations even without horizontal movements. Plus, it has proven that one event can trigger more drips that can change Earth's surface. This discovery helps scientists better understand how Earth's crust behaves over long periods of time and how tectonic processes can affect the landscape. Now, how about a bonus fact? In 1692, Edmund Halley, that guy famous for Halley's Comet, suggested that Earth might be hollow. He imagined layers beneath the crust with two concentric shells and a core about the size of Mercury, all floating in glowing gas. He even went further, speculating that these inner layers could be inhabited. This wild idea inspired Jules Verne's famous novel, Journey to the Center of the Earth. Wow!
About a third of all grown-ups have a snake phobia. But if you decide to become an astronaut not to have to deal with them, it might not be a great idea. According to Story Musgrave, there are snakes in space. Musgrave is one of the most experienced astronauts in the world right now. He is the second astronaut who managed to go on 6 space flights and fly on all the space shuttles. With that much experience and time in space, he has to have 1 or 2 space horror stories in his career. Once on a space mission, he looked out of the window and saw something resembling a snake. Musgrave said it was 6 to 8 feet long and looked like a snake. But many people don't believe his story. They claim it was some trash floating in space or something that had detached from the spacecraft. But the astronaut went on another mission and saw the creature again. The first time he spotted it, it could be some detached piece from the spacecraft. But what are the chances of that happening twice? He gave many interviews in which he explained these crazy encounters. Let's hope those snakes stay in space and don't come crashing down on Earth. If they are real, of course. Snake rain would not be fun. As we all know, space is like a giant vacuum chamber with zero air, and sound can't travel there, making this story even more terrifying. To communicate, astronauts have a special system in their suits to exchange information. Young Li Wei shared his terrifying experience, and it's hard to believe it actually happened. You would be terrified if you were alone at home and someone started knocking on your door at night. Of course, if you weren't expecting anyone. Imagine the same scenario, but you're in space. You hear some knocking. You have nowhere to run. You're trapped in a metal can, floating into nothingness. Young was sitting in his spacecraft, minding his own business, when he suddenly heard knocking coming from outside. How is it possible? Sound can't travel in space. The noise was unique. The astronaut described it as if someone had been knocking on an iron bucket with a wooden hammer. Li Wei looked outside, but to his surprise, there was nothing there. He investigated a bit more, but couldn't find the source of the sound. When Young returned to Earth, he was eager to tell scientists about what had happened, but he could not recreate the sound. To add fuel to the fire, his colleagues, who were on the same mission from 2005 to 2008, said they had also heard knocking similar to what Young had reported. This is still a mystery. Nobody knows what happened then. Maybe it was just spacecraft noise, like those your house randomly makes. We've already mentioned that sound can't travel in space, but that doesn't stop weird noises. The Apollo 10 mission was one of the most significant space missions ever, so astronauts had to ensure everything was perfect before they went on a moon exploration journey. 3 people were on that mission: Thomas Stafford, module pilot John Young, and lunar module pilot Eugene Cernan. They had to do tons of gear tests for the upcoming Apollo 11 missions. The astronauts were circling the moon when they heard music coming from somewhere. It wasn't like Ed Sheeran's concert, it was more like constant loud screaming. Then, it was quiet whistling. They were terrified. Imagine being in space for the first time and hearing weird noises. The sounds lasted for a whole hour. The astronauts had never heard anything like that before. The sound was otherworldly and creepy. When they returned to Earth, they didn't know if they should tell someone about their experience because it was hard to believe. Michael Collins, an astronaut from the Apollo 11 mission, later shared that he had also heard this sound. But there is a kind of logical explanation for this. Engineers from NASA said that the sound that they had heard had been caused by the interference with the communication system. So you can relax and throw your tinfoil hat in the trash. But before you do that, Al Worden, an astronaut from the Apollo 15 mission, said that this explanation was unlikely, so we might never find out what really caused the sound. Leroy Chiao was the commander of the International Space Station in 2005. When it comes to space, he's seen a lot of things that can send chills down your spine. One encounter he and his crew had will live on in their head rent-free forever. Chow was sitting in the space station doing his job when he suddenly spotted light from the corner of his eye. He took a closer look, and it resembled an upside-down V, floating and glowing in space. Leroy later explained that he hadn't been scared by the object. Quite the opposite. He was extremely excited to see it, even though he had no idea what it was. His crew also saw the strange object. Chow was convinced he was visited by something not from Earth. His team could also vouch that indeed they saw something unexplainable. The information about this encounter is all over the internet, and many people are skeptical. It could have been anything. There are more than 10,000 satellites in space right now. It could have been a satellite floating in space. Another theory is that those were lights reflecting from a fishing boat on Earth. But who knows? There may be another logical explanation for this phenomenon waiting to be discovered. Horror stories don't stop there. This one is hard to believe, and it's up to you to figure out if it's true. Astronaut Alan Bean was the 4th individual to set foot on the moon's surface. When he was on the Apollo 12 mission, he claimed he saw a unique shape on the moon. It was shiny and shaped like a shoe. It's hard to know what he saw because he passed away in 2018. Chinese lunar rover Yutu 2 also discovered some shiny substance on the moon. Scientists say it was something gel-like. It could be a glaze that formed when something impacted the moon's surface, like a meteorite or something else. But in the future, we might find a better explanation for this strange find. This may sound wicked, but many countries send animals to space before humans follow them. Take Miss Baker, a squirrel monkey, Ham the chimp, and many more. Many of these animals returned to Earth safely and lived happily ever after, like Ham the chimp that lived for 26 years. But some weren't so lucky. Astronauts are still creeped out when they see animals floating in space. Imagine seeing something like that in a dark vacuum. No matter how tough you are, after that, you will be afraid of your own shadow. This may be sad, but it was an essential step in space exploration. The following horror story comes from space engineer Musa Manarov. This guy came across something that made scientists confused. He was shooting a video of space when he accidentally filmed some shiny object flying in the distance. The thing had a cylindrical shape, and Manarov thought it was something that had detached from the spacecraft. But he was unsure because it moved in a unique way. When you think of a creepy space story, the first thing that comes to your mind is some creature crawling on the spacecraft, or some weird object flying in space. But all those things are highly unlikely to happen. When somebody asked Chris Hadfield what the scariest thing about space was, he said it was asteroids. There are thousands of them in space, and the spacecraft is constantly getting hit by them. Chris said that he'd always heard sounds from asteroids hitting his spacecraft. He also mentioned that the spacecraft's solar panels were covered with holes. And you never know whether a giant asteroid will come and hit your spacecraft.